Deleting every name protects privacy, but can destroy the relationships an LLM needs. Compare Redaction with Presidio pseudonyms to keep context without sending raw PII. You'll learn how the pieces fit into a workflow that compares removal with pseudonyms and restores only approved values. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. People reach for redaction and pseudonymization when they need models to reason about private conversations without leaking secrets. The practical problem is simple. You want the model to keep who did what, while you never send raw, personally identifiable information. Success looks like useful model behavior and clean audit trails with no raw names and logs. Intuitively, redaction is blunt. You remove the sensitive token and the model loses a link between mentions. Pseudonymization replaces the token with a stable alias, so the model keeps relationships but never sees the original value. Each approach trades privacy for context in different ways. We will build a tiny gate that receives detected Presidio hits, shows blanket redaction, applies deterministic pseudonyms, and then restores only approved values after the model replies. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Let's start by turning detected offsets into the object shape our gate expects. This snippet turns known PII offsets into Presidio recognizer result objects for the rest of the gate. It converts tuples of entity, start, and score into recognizer result instances, so downstream steps can rely on consistent attributes like start, end, and score. In a real pipeline, those hits normally come from AnalyzerEngine.analyze, but here they're fixed, so the demo is deterministic. The code walks the list, constructs each recognizer result, and prints a count, confirming the gate sees 3 spans to handle before any prompt leaves the app. Now we want to see the cost of the simplest safe option, so we try full redaction. This example removes every Presidio hit with AnonymizerEngine, so the cost of blanket redaction is visible. It builds an operator's mapping that applies operator config redact to every detected entity, which preserves surrounding words but deletes the sensitive values. That's the safest exposure-wise, but it also erases links between repeated mentions, so the model can no longer tell who acted twice. The snippet prints the redacted prompt and a small metric for how many characters were removed, giving a quick sanity check for how much context disappeared and whether downstream reasoning still has enough signal. Since redaction loses links, next we build stable aliases so repeated mentions stay consistent. This code builds deterministic aliases from Presidio hits and compares preserved context against the redacted prompt. It creates an alias map from sorted original values, so the same input always gets the same token, and it replaces spans from the end of the string backward to avoid shifting remaining Presidio offsets while editing the prompt. The snippet shows how alias tokens are formed and applied, then prints the pseudonymized prompt alongside the redacted version, demonstrating that pseudonymization preserves word-level context and keeps the repeated reference to Ava that blanket redaction removed. After a model answers, we must only put real names back when policy allows, so we test selective reveal. This snippet restores only an approved alias after a model-style reply comes back. Given a model reply that still contains deterministic tokens and an approved map for this response path, the code swaps back just alias Ava, while leaving alias Ben masked for logs or tickets. It walks the reply, matches alias tokens, and replaces only the approved ones, then prints the partly restored response and a count of aliases still masked. The output shows one alias still present, and the approved value restored. Exactly the guardrail you want after the model responds. Finally, we package the flow into a single gate, so the pattern is clear and reusable. This example packages the alias prompt, model call, restore step, and leak counter into one tiny gate. Privacy gate accepts the original prompt and Presidio-derived hits, sends only safe prompt to call model, and then applies the approved restoration map on the way out. Call model is a compact stand-in for your LLM API, so the privacy control stays visible without provider-specific boilerplate. The snippet reports what was sent, how many spams were checked, and the final response after selective restoration, showing no raw values in the sent prompt, 3 checked spams, and a final reply that restores only the allowed identity. In a real project, this pattern plugs into your request middleware. Use the same privacy gate before every model call. Log only the pseudonymized prompt, and keep an audited map of approvals for each response path. Summed up, Redaction removes raw data but breaks cross-mention reasoning. Pseudonymization preserves relational context while keeping the original values out of the prompt. Watch the approval step closely, because restoring even one identity increases exposure risk. A concrete next step is to run privacy bait across your support transcript corpus and measure how often the model produces a raw name with different approval policies. Then tune the approval rules until the leak rate meets your compliance threshold. If practical AI engineering helps, subscribe for clear tutorials on privacy and LLM systems.